Hello, this is Mr. Stansbury. I'm going to take you through the notes on radical expressions versus rational exponents. At the end of this, you should be able to say I can convert expressions between radical and rational exponents, and I can explain how to convert between radical form and rational exponent form. Okay, so first let's look at the two different forms. So we've got a radical expression, and here's our rational exponents. So radical expression is basically with our little root sign here, and then this 3 out here, we call that the index. That would mean that this is the cube root of, or if there's nothing out there, it's the square root, fifth root, whichever. This is our radical sign. The piece underneath the root symbol is the radicand, so that's our x squared, and this whole thing all together is called the radical. Okay, the rational exponent is where you take your base x, and then you write this as a rational exponent, which is the power over root. So actually this here, this cube root of x squared, is the same thing as x to the 2/3, because what you do with this here is it's saying here our rational exponent over here is power over root. So we have, in this case, we have x to the second, and it's the third root, so it's x to the 2/3, and hence we have that right there. Okay, I'm going to erase that to give us some more room here for our next piece. We're going to rewrite each expression as a radical, and then we're going to simplify it. So we're going to take it from this rational exponent form and turn it into a radical. So the 16 is going to stay there. This is going to be our radicand, and then whatever the 3 on the top is the power, so it's 16 cubed. And then we're going to take that to the fourth. We're going to have that as the fourth root of 16 to the third. Okay, so what we really can do here is we can take the fourth root of 16, right? Because we can write 16 is the same thing as 2 to the fourth to the third, right? Because that 16, all we did was just change 16 into the fourth. Okay. Okay, and so really what this means here is that this fourth root and fourth power are going to cancel each other out, so we're going to just be left with 2 to the third. Okay, if you don't like that, another way we can look at this would be we could rewrite this as the fourth root of, this is 4 times 3, so this is to the 12th power. So we could we could rewrite this as 2 cubed to the 4th power, right? And then this 4th power and 4th root cancel out, so we're left with 2 to the 3rd, which is just 8. Okay? This one over here, we've got -8 to the 2nd power, and we're going to take the cube root of that. Whatever's on the bottom is always the root piece, and the top is the exponent, the power. Okay, so we've got this here, and we can take, let's see, -8 is the same thing as -2 to the 3rd power, right? So that's -2 to the 3rd all to the 2nd, right? So basically that 3rd root and 3rd power cancel each other out, and so we get -2 squared, which should just give us 4. To make this more accurate, we really should have put this -8 here in parentheses here, so we know we're taking -8 times -8, because that's what they have in parentheses there, and then that will work out to our 4. Otherwise we might have some little issues there. Okay, this one over here, 25 to the 3/2 power. That means we have the 2nd root. We don't have to put the 2 out there, because if it's not there, it's assumed that it's a 2. And then so on the inside we have 25 cubed. Okay, so we can rewrite 25 as 5 squared, and that whole thing there to the cubed power, right? So this square and square root, the square and the square root cancel each other out, so we should be just left with 5 to the 3rd, which is 125. And just to give you a little bit of hopefully satisfaction here, 25 to the 3/2, we put that in our calculator. 25 to the 3/2 tells us that it's also 125. Okay? Okay. Let's see. Last one here, and we'll do one more after that. But we got negative 27 to the 4/3, negative 27 to the 4th power, and we are cube rooting that, right? So the cube root of negative 27 is simply negative 3 to the 3rd, all to the 4th. So this cube root and 3rd power cancel each other out. We get negative 3 to the 4th, which is going to be, what, 81? Because negative 3 times negative 3 is 9. And then another negative 3 times another negative 3 is another 9. 9 times 9 is 81. Okay? Okay. Okay, we got one last example set to go through, but let's take a quick little comedy break first.
He's standing on the ball. He's gonna fall. He's standing on the ball.
All right. Rewrite the radical expression with rational exponents. We don't even have to solve. We're just rewriting it. So this is going to be, oops, keep doing that. So this is going to be a 4th power over 3rd root. So a to the 4/3 power. Done. 27 is really to the 1st, so that's going to be to the 1/3, and then a is going to be to the 4/3, because a is to the 4th power. That's 27 to the 1st. So we'd want to write it like that. Okay. This is going to be 9. That's still already to the 1st power, so that's 9 to the 1/5 times, times x to the 10/5, which we can actually simplify that, so we would rewrite that as 9 to the 1/5 x squared. Okay, and then last one here we've got that's 16 to the 1st, so we do 16 to the 1/4, and then z to the 2/4. We can actually simplify both of these because 4th root of 16 is just going to be, well, I guess it didn't say to simplify, did it? So we'll just leave 16 to the 1/4, and then we'll do z to the 2/4 is actually z to the 1/2 if we just simplify just the fraction. We could, again, also write this 16. The 4th root of 16 would just be 2, so we could write that as 2z to the 1/2 as well. Okay? All right, that's all we have for the radical expressions versus rational exponents. If you have any further questions, please feel free to ask in class. Thanks.